At ERIEZ Magnetics, we have the best workers in the industry. We value their health and their safety in the workplace. We seek to have a workplace that prevents accidents. Therefore, training and instruction and tools are very important, as well as maintaining a clean, well-lit, and well-maintained workspace. However, if accidents happen, then we have to have a solution for that. Magnets produce a special hazard. They are a stored energy device. An employee can become trapped between a magnet and another magnet or piece of steel. If that situation should occur, it's important that we extricate that employee safely and quickly. The magnet release video that you're about to watch will help you in that job should you be asked to assist another employee. Please give this video your undivided attention. Thank you.
Ever-changing work environments make it necessary to review effective and safe work practices on a daily basis. Being safety conscious is an important responsibility we all share at work and at home. Today, we'll address the safe work practices and potential hazards associated when working with magnetic devices. This video is designed to help you better understand the basic properties of magnets, how to establish and practice safe habits when working with magnetic devices, how to be prepared when working with magnetic devices, how to conduct the emergency extrication of a person trapped by a magnetic device, how to provide basic first aid to a person trapped by a magnetic device. Magnets 101. A magnet is a material that can exert a noticeable force on other materials without actually contacting them. Known as magnetic force, it may either attract or repel. All magnets have 2 points known as poles, where the magnetic force is the greatest. For a rectangular or cylindrical bar magnet, these poles would be at opposite ends. One pole is called north, while the other is called south. Unlike magnetic poles attract, while like poles repel. The attracting or repelling strength is a function of distance between them. This invisible force can draw 2 or more magnetic devices or ferrous debris together without warning. There are 2 basic types of magnets. The first is a permanent magnet, which exerts a force on objects without any outside influence. The iron ore magnetite, also known as lodestone, is a natural permanent magnet. Other permanent magnets are made by subjecting certain materials to a magnetic force. When the force is removed, these materials retain their own magnetic properties. Such magnets are considered to be permanently magnetized, hence the name. The second is known as an electromagnet. Electromagnets are made by winding ferrous materials with a coil of wire. When an electric current is passed through the coil, these materials exert a magnetic force. When the current is turned off, the magnetic force drops to nearly zero. The first step in electromagnet safety is to be sure the electromagnet is turned off before beginning work or servicing. Caution should always be used, whether or not the electromagnet is energized. All magnets must be handled with extreme care. Plan ahead. Be prepared. Be aware of your surroundings and of the equipment involved in your job. Doing so will help keep you and others free from potential injury. Planning ahead involves reviewing the types of magnetic devices or materials with which you will be working. What types of magnets are they? Remember, Permanent magnets are always magnetically charged, and therefore always on. Are they electromagnets? Is the power source in the on or off position? Is it safe to approach the work area with your tools? The work area should be well lit and clear of all debris, unrelated equipment, or magnets that could be drawn into the magnetic field. Additional magnets should be placed safely away from each other or stored and separated by non-magnetic barriers, such as wood or plastic. Special care must be taken when storing charged magnets. Barriers between magnets should be chosen according to the pull strength of the magnets. Thicker barriers may be required for stronger magnets, such as rare earth. When storing charged magnets, the physical orientation of the magnet with respect to its polarity and the polarity of adjacent magnets is important as well. Consider a permanent magnet block that has its north pole facing upward. Magnets that are placed adjacent to this block should also have their north pole facing upward. This arrangement will make the blocks repel each other, reducing the likelihood that they may snap together. Referring to the same block, with its top surface a north pole, magnets that are stacked above that block should be separated by a non-magnetic spacer and have their top surface also a north pole. This will cause the magnets to be attracted to each other in a controlled manner. In some situations, it may be useful to position permanent magnets on a thin, non-magnetic spacer positioned on a steel plate to help prevent the magnets from moving. However, polarity orientation of adjacent magnets must still be considered. Before energizing an electromagnet or entering an area where an electromagnet is located, be sure that the area is clear of ferrous steel tools, chains, or other ferrous objects that may become attracted to the magnet. The simple act of lifting an object may start its acceleration toward the magnet. Your body will not diminish or attenuate the attractive force of the magnetic field. There is no shielding from a magnetic field. Therefore, serious injury or even death are very real concerns. Emergency magnet release and extrication. In the event of entrapment, there are special emergency procedures to follow. All personnel should be aware of basic extrication techniques for a magnet release emergency. A magnet release kit is a collection of non-magnetic tools and basic first aid supplies to assist a person who has become trapped by a magnet. The kit must be well labeled and stored in an area so that it's easily located, accessible, and in close proximity to areas where numerous magnetic devices are made. Debris, boxes, or other potential hazards should never block access to magnet release kits. Their inventory should be checked at the beginning of each shift. The kits must only be used in the event of an emergency. Note that tools in ERIEZ standard magnetic release kits are painted orange to identify them as such. These kits consist of the following items: 1 Tech-Tough black case, 1 green and white ID nameplate, 1 first aid kit, 1 set of ceramic demonstration magnets for polarity check, 2 stainless steel gusseted bent pry bars, 2 large stainless steel bent pry bars, 2 small stainless steel bent pry bars, 3 stainless steel straight pry bars, 2 aluminum straight pry bars, 2 9.5-inch oak wood blocks, 8 8-inch oak wood wedges, 8 4-inch oak wood wedges, 2 6-inch aluminum wedges, 2 4-inch aluminum wedges, 2 2-inch aluminum wedges, 1 18-inch quick bar clamp, 1 12-inch quick bar clamp, 1 large non-magnetic red tip hammer, 1 small non-magnetic red tip hammer, 1 Enerpack hydraulic pump with a hose and spreader. The most commonly trapped body parts are hands or fingers. However, it is possible to have a large magnet trap a larger portion of a person's body. Such entrapment may occur between 2 magnets or a magnet and another ferrous object. That object could be a stationary workbench or ferrous debris, such as spare tools, industrial chains, or other such material. These materials could be pulled toward the magnetic field at great velocity. If you are called to the scene of an accident involving magnets, it is important to remain calm. First, assess the scene. Approach the trapped person in a calm and reassuring manner, explaining you are there to help. Call a member of the first aid committee immediately. Advise the victim not to attempt to pull his or her hand or extremity free, as this could cause further injury. Clear the area of all magnets and other ferrous objects, as they can be drawn into the magnetic field of the accident area, which may cause further injury. Determine a plan of action and notify emergency medical services if the situation warrants it. Be sure to communicate your plan with the trapped person and other rescuers. One person should remain with the victim at all times, providing support and reassurance. Another person should be in charge of coordinating the extrication at the scene. That person would first determine where to apply any necessary clamps to secure magnets or debris below the magnet and trapping the person. Caution must be used when applying the clamps, as they may also be ferrous and may be attracted to the magnetic field. Once the magnet or debris has been stabilized, wedges can be tapped into place to relieve pressure from the pull of the magnets. These wedges should be tapped into place while another rescuer supports the magnet. Use care when working with aluminum wedges, as they may slide. If need be, wooden wedges may be tapped into place near the aluminum wedges to further stabilize the magnets. Tapping these wedges into place will eventually create free space, allowing pry bars to be inserted. Once a pry bar is inserted into the free space, the lead rescuer holding the pry bar securely will push the pry bar downward. The opposite end of the pry bar will move upward, raising the magnet away from the victim's hand. The fulcrum point should be opposite to the victim's body part. The rescuer securing the magnetic device should move that device away from the victim, never towards them. Be sure there is enough room for both the rescuer applying leverage and the rescuer stabilizing the magnetic device. If two smaller magnets trap a victim, it may be advantageous to move the victim to a more secure location to perform the extrication. Carefully support the victim's hand or fingers and magnets and set them onto a non-magnetic table. The rescuers can then utilize the same extrication techniques as described already. Quick release kits should be highly visible, hanging in a prominent area that is easily located and always accessible. The tools for the quick release kit are painted the same color orange as those in the standard magnetic release kit and should not be utilized for any other purpose. Other types of entrapment may incur special circumstances. Great magnets, rare earth magnets, or large-scale magnets may require additional extrication techniques, including the use of an inner pack or hydraulic separator. Local emergency medical services and other specially trained personnel should be notified and on scene to assist with these types of extrications. The inner pack comes with complete instructions and should be familiar to all trained in magnet release emergencies. For large-scale or strong pull force magnet extrications, the rescue team would begin with the same steps described earlier. Tap wedges into place, creating a free space large enough to insert the nose of the inner pack. The inner pack must be used with caution, as it is also magnetic and will be attracted to the magnetic field. Once inserted into a free space, the hydraulic force of the inner pack may be applied to separate the magnets and trapping the victim. Providing first aid. Once the victim is released, the first aid team will provide appropriate care, including contacting 911 if necessary. Dry, sterile dressings, ice, and elevation of the affected area are recommended. Keeping employees away from danger, aware that accidents may occur, and providing information on how to best handle emergency situations are absolute necessities. Training and knowledge are critical to ensure that everyone remains safe on the job. Remember that safety is a priority, and being ready to help others in need is invaluable.